Dark matter is the most common stuff in the universe. There's more of it than anything on the periodic table. And it's just embarrassing then that we know almost nothing about what it is. What we know about it is things that it's not. It's not on the periodic table. It's not the normal kind of matter that we know about, that science has studied, or that we're made out of. And it doesn't shine in any way. It's completely invisible.
So how do we know it's there?
We know that dark matter's there because of its gravitational influence on everything else. Even around our own galaxy that we live in, the Milky Way, there's a load of dark matter swirling around and whizzing through us now all the time. It passes straight through us and we don't see it. But it's almost as if there's this extra world going on around us. It's crucial that it's there for us because its extra gravity acts as a sort of glue that holds the Milky Way together and every galaxy. As the Milky Way is spinning round and round and round, it's like a pizza dough that you spin out. And when you spin a pizza dough in a kitchen, it's the stickiness of the dough that holds it together and stops the dough splattering over the walls of the kitchen. Well, when the Milky Way is spinning round, what holds all the stars together is the force of gravity. And when you just add up how much gravity there is from the stars that we can see, there isn't enough. The Milky Way is spinning so fast that by rights all the stars should have been flung off into outer space. Fortunately, there's this dark matter, and its extra gravity holds the Milky Way together.
So we have this stuff. We can detect its presence through the gravitational effect it must be having. It's critical for the fabric of our galaxy and many other galaxies, we infer.
Yeah.
But if we can't actually detect it, how can we learn more about it?
Well, there's a little trick that we can use to detect it, and it's just like anything else. There's lots of things that you can't see, but that you know are there. You can't see the wind, but you know it must be there, and you know which direction it's going because there are leaves blowing in it. And dark matter really does affect everything around it through gravity. And we use a trick known as gravitational lensing to map out where the invisible dark matter is. All this is it's a bit like looking through a bathroom window. That when you look through a bathroom window, the glass itself is transparent. But you know it's there because all the streetlights on the other side of the road appear distorted and curved. Well, when we look through some dark matter, it bends light rays passing through it, and although we can't see the dark matter itself, it makes the images of galaxies and other things in the background appear distorted and stretched. And so we can map out where the dark matter is using this trick.
And what has this taught you?
What we've done in this particular study is look at a patch of the universe where a couple of lumps of dark matter, or a couple of galaxies with dark matter, have smashed into each other. If you want to figure out what stuff is made out of, what we'd do on Earth is we'd smash a couple of things together. We'd hit a rock with a hammer, or we'd build a tunnel under Geneva and smash atoms into each other. All we've done with this experiment is to do the same sort of thing, wait for nature to throw a few lumps of dark matter at each other and see where the bits fly, so we can work out what they're made out of.
These galaxies come together. They've got their associated dark matter.
Mm-hmm.
As they collide, you're looking through that gravitational lens caused by the presence of the dark matter. What happened when the galaxies collided then?
What we found with this is that rather than the dark matter passing straight through each other, as we'd expected if it doesn't interact through any force other than gravity, what we found is that the dark matter has for some reason ended up in a slightly different place than it ought to be. This is a big mystery, but it matches exactly the predictions made by supercomputer simulations. If dark matter has a very slight feel for the rest of the world other than through gravity, if it feels enough of a friction to slow down very slightly.
So what's the implication and the importance of this? Because it's one observation in a whole universe. Why does this have a fundamental influence or impact on our thinking?
Well, we've been trying to hunt what dark matter is for a very long time, and we keep ruling out things that it can't do. Finally, to be able to say that maybe it's actually doing something is the first step to being able to figure out, well, what is it? This most common stuff in the universe that we really want to know what it is. We can now start following up ideas that, if it does this, maybe it could be this particular type of particle. And there are lots of theories about what it might be. Particle physicists have come up with all sorts of ideas. The best thing that we can do now is start to try to rule out some of those and investigate what properties the dark matter might have.